All right, last time we did some what's called dimensional analysis. And let me show you what that dimensional analysis looks like by dragging this chart over here for a second. Okay, so essentially the dimensional analysis is what we call it when you write an equal sign, you draw the units that you're interested in having over here, and then you draw a line, and then that line provides a spot here for you to draw or write the numbers and the units that you start with. Okay, and we said if I have 1.1 meters, then I know my units down here have to be meters. And all of that drawing right there provides you like a map or a proof, or you can think of it as a blueprint, ways to look at it visually and see that you are where you're headed. Feet over here is where you're headed. Where we're starting is meters. Okay, so in the last example, we went from meters to centimeters, and then we knew that we had to have centimeters down here. And do you remember, where did we go after we were in centimeters?
To inches.
That's right, we went to inches. And then after inches, where did we go?
Feet.
Feet. That's right. And even without the numbers, you can see the meters will cancel out here, the centimeters will cancel out there, the inches will cancel out there, and I'll be left in feet. And then you do want to make sure that you put the appropriate numbers. You have to make sure you look at this until you're confident that there's 100 centimeters in a meter, right? So 2.54 inches, 1 centimeter. Is that right?
Yeah.
Did I do everything right? I didn't do something right. Look and see what I did wrong.
2.54 inches equals 1 inch, not 1 centimeter.
Yeah, 1 inch is 2.54 centimeters, right? Okay, very good. So it's very important to pay close attention to that. Okay, so that is called dimensional analysis. And we're going to use dimensional analysis to answer this question here. This question here. All right? So if we have 2.54 centimeters in every inch, how many kilometers are there in 25 feet? All right? So I'm going to see if you can try to do this one, all right?
Yeah.
What do we do first? Good job. We draw a line with what else? An equal sign. Excellent. Very good. Now what's next? Very good. We identify our units and we put them to the right of the equal sign. Excellent. Now what? I'm going to extend this line just a little bit because we might need every last inch to get this one done right.
Okay.
Okay, what's next?
Is it 25 centimeters?
Oops, here we go. 25, what is it? Feet. Very good. So where do we write 25 feet? Very good, 25 feet. Excellent. And then we have a line right there, right? What's next? What can we do next for free without thinking? Feet. Very good. Now keep it nice and tight because we might need to use a lot of this space. Very good. All right. Now, where should we go? What should we convert feet to? They gave us inches to centimeters up here.
2 inches.
Yeah, we can go feet to inches. Good. Go for it. Okay, good. And then what do we do? 12. Okay, 12 inches for every 1 foot. Excellent. And what goes down here? Very good. Now where are we going to go with our inches?
Turn it into centimeters.
That's right, centimeters. Good. I'll turn this C around for us. Okay, now what? Whoops, other way. Good, centimeters.
We need to do the inches.
Oh yeah, we didn't finish up here. You don't have to do the numbers first, but that's all right. We can do the numbers. What is the relationship there?
1 inch.
Uh-huh.
2.5.
Good. 2.54. All right, now, what should we go? Centimeters to what? If we got to get to kilometers, where should we go? You choose something you know.
Millimeter?
How about just meters?
Oh, meter.
Millimeters would be going smaller, but meters, yeah. And then down here goes what? Meters. And where are we going to go?
Kilometer?
Yeah, because kilometers. Hopefully you remember how many meters there are in a kilometer and how many centimeters there are in a meter. 1 meter? Is it 10 meters per centimeter?
Yeah.
Think about it.
Right.
Think about it. How big is a centimeter? It's about as big as your thumb, is that right?
Yeah.
And how big is a meter? Is that smaller than a centimeter? And what does centa stand for in centimeter?
A meter?
No, centa is century. Do you know what a century is?
10 years.
Nope. A cent. Do you know how many cents there are in a dollar?
100.
100. So cent stands for 100. So there's 100 centimeters for every 1 meter. Very good. Now, how about meters in kilometers?
3.
No, a kilo means 1,000. So in 1 kilometer, we have 1,000 meters. 1 kilometer, 1,000 meters. Okay, very good. Now, do you have a calculator nearby? Can you try to answer or figure out the answer?
Yep.
So what are you doing in your calculator? So when you multiply the top ones and divide it by the bottom ones, you said you got 0.00762? Is that one of these answers?
Yeah.
No. So none of these, right? Very good. You got 7.6 times 10 to the minus 3 kilometers, right? Very good. So it's very, very small. It's much less than 1 kilometer, which makes sense. It's only 25 feet. A kilometer is big, right? All right. Very good. That was a good practice for doing dimensional analysis. All right. So let me introduce to you another property of material, which we call density. So I'm going to introduce to you a concept called density, but I think it's probably better for us to wait till next time. So this video here will be a good review for how to do dimensional analysis. Okay, good.